From the first measurements to the final launch, every stage of boat building is a test of skill, precision, and generations of hard-earned knowledge. But one small mistake made today could remain hidden for months, only to reveal itself when the vessel finally faces the unforgiving power of the open sea. As a new fishing vessel begins to take shape, experienced craftsmen gather at the boatyard to tackle one of the most important phases of its construction. Before a single piece of the vessel's massive structure could be installed, the foundation beneath it had to be prepared with absolute precision. The cradle is carefully positioned and secured, creating the support system that will carry the weight of the growing boat throughout construction. Only when every support is aligned correctly can the next stage begin. Waiting nearby is a gigantic hull plank stretching more than 17 meters in length, a piece so large that moving it alone becomes a challenge. Its size leaves little room for error. One wrong movement could damage the timber, delay the project, or create problems that follow the vessel long after it reaches the water. With the framework ready, the workers begin the slow and deliberate process of lifting the enormous plank into place. Suspended above the construction area, the massive timber is guided inch by inch towards the hull, while every pair of eyes remains fixed on the operation. The most demanding part is not simply moving the plank. It's ensuring that a piece of wood this large settles perfectly into position. The vessel being built is a trap net fishing boat measuring approximately 22 meters in length and approximately 6 meters in width. While its final form is still emerging, each completed section brings it one step closer to becoming a fully operational working vessel. Nothing about the process happens by chance. Every stage must be carefully coordinated, with measurements checked, components aligned, and heavy timbers fitted into place with precision. Slowly, piece by piece, the outline of the boat begins to appear. What starts as a collection of massive wooden sections is gradually transformed into a vessel capable of carrying crews into open waters, where strength and reliability will be tested every day. Wood is not selected at random here. Every piece is chosen with intention, as if its history already matters to the future of the vessel. These are materials that have proven their worth long before modern metals and synthetics ever entered shipbuilding. Species like teak, mahogany, and oak are especially valued, not just for their beauty, but for what they survive. In this yard, wood is treated less like raw material and more like a living structure in waiting. Each beam is inspected, tested, and silently judged. Because once it is placed into the hull, there is no easy replacement. Out at sea, there is only endurance or failure. The frames are crafted with meticulous care, each one shaped to match the vessel's intended form. Nothing is generic here. Every curve is calculated, every angle refined, all in service of a hull designed for stability and dependable performance on rough waters. Set along the keel and rising toward the stem, these frames begin to form something that feels almost alive. A skeletal structure slowly giving the boat its identity. The flat bottom design becomes visible in these early contours, promising balance and control once the vessel finally meets the sea. But beneath this precision lies pressure. Because each frame does more than define shape. It determines volume, buoyancy, and how the boat will respond when the ocean stops being calm. A few millimeters off now, and the difference may only be revealed when there is no room left to correct it. The design of the boat is driven by function above all else. Nothing here is shaped for appearance alone. Every hull line is drawn with a single purpose in mind: survival and performance in open water. Stability comes first, then load capacity, then seaworthiness under conditions that can shift without warning. Each decision is measured against how the vessel will behave when fully loaded. Timber selection is treated with strict judgment, almost like a silent test of character. Not every plank is allowed to move forward. Only those that meet uncompromising standards are chosen for open ocean work. Knots, cracks, and hidden flaws are rejected without hesitation, set aside, discarded, because in this craft, weakness does not stay hidden for long. The sea does not forgive what is overlooked here. It reveals it later, when correction is no longer possible. Before construction moves forward, the timber is given a pause. The wood is allowed to rest and slowly acclimate to its working environment. Temperature shifts, humidity, and surrounding air all begin to influence its internal balance. So, the vessel waits with its materials in silence. Not because progress has stopped, but because stability is being earned before the next stage begins. With the main structure beginning to define the vessel's shape, attention now shifts to the interior framework. The installation of the thwarts marks a critical step in turning an empty hull into a functional working boat. On the surface, it appears simple, just wooden beams placed from side to side, but in reality, each one carries structural weight, binding the hull together and reinforcing its rigidity under stress. Planking is the stage at which the vessel's framework is transformed into a solid, watertight hull. Curved planks are formed using the charring process, where controlled heat is applied to the timber to make it pliable enough to follow the hull's demanding shape. The wood is carefully exposed to controlled heat, slowly warmed by fire until it begins to change its behavior. What was once rigid starts to soften, following the complex curves of the hull. Long, carefully shaped wooden boards are now brought into position, beginning the process that will close the vessel's exposed skeleton. One by one, they are fastened to the structural frame, gradually enclosing the hull and giving the boat the form it needs to float and function at sea. This build follows a frame-first method, where strength is carried by the internal structure rather than the outer shell alone. Even the smallest components in this vessel carry consequences that reach far beyond their size. The choice of fasteners is one of those unseen decisions that quietly determines how long the boat will survive once it leaves the safety of the yard. Each nail, screw, or bolt is selected with deliberate care, not for convenience, but for endurance. Corrosion resistance becomes just as important as strength. Compatibility with the surrounding wood matters just as much as holding power. If the metal reacts poorly with the timber, decay can begin silently, spreading long before any visible signs appear. To hold the wooden components firmly in place while permanent fastenings are applied, large clamps and chain holders are brought into use, applying strong, adjustable pressure across the structure. This is a standard yet critical practice in traditional boat building, especially when working with large, heavy timbers that naturally resist alignment. The force is not sudden, but carefully controlled, tightened step by step until each piece is drawn exactly into position. But before the hull can be sealed, the builders stop to deal with a problem that could destroy the vessel long after construction is finished. Water. Not the waves crashing against the outside of the boat, but the moisture that can work its way deep into the wood and remain hidden for years. To prevent that from happening, the timber is carefully treated with an anti-moisture coating. The masters guide a power drill into the timber, preparing holes for thick metal rods that will help hold some of the vessel's largest and heaviest components together. These are not ordinary fasteners. They are used where the loads are greatest, and where failure is simply not an option. Massive wooden members are drawn together using through bolts, creating connections strong enough to withstand years of stress, vibration, and the constant motion of the sea. The frames are the hidden ribs of the vessel, the structure no one sees once the boat is complete, but the part that decides everything. One by one, the planks are lifted into place and fastened directly to these frames. And with every connection, the boat starts to change. It stops being separate pieces of wood. It starts becoming one body. At first, there's still movement in the structure. Small gaps, slight flecks. But as more fasteners go in, that movement disappears. The hull tightens. The shape locks in. And what was once just a skeleton in a boatyard begins to feel solid, permanent, and alive in its own way. Each frame carries pressure. Each plank spreads it. Together, they form something far stronger than either could be alone. In woodworking, joints decide the strength of everything. But in boat building, they decide something even more critical, whether the vessel survives what it meets at sea. Every connection matters, but few are as important as the point where the stem meets the side planks. This is the very front of the hull, the part that goes first into the water, the part that takes the first hit of every wave. As the structure comes together, this junction is shaped and fitted with extreme precision. The timbers must meet perfectly, with no weakness left between them. Because once the boat leaves the yard, this area will not get a second chance. Here, every force begins its journey through the vessel. The impact of waves is absorbed at the bow, then carried along the frames and distributed across the hull. If this connection holds, the entire structure holds with it. If it fails, nothing else matters. In traditional boat building, one of the most trusted fasteners is not metal at all, but wood itself. Tree nails, small tapered pegs carved from dense hardwoods like oak, locust, or holly, are driven deep into pre-drilled holes to lock planks tightly to the frames beneath them. What looks simple on the surface hides a powerful mechanical principle working overtime. Once exposed to moisture, both the tree nail and the surrounding timber begin to swell. The joint tightens on its own. Pressure increases from within, and the connection becomes even stronger than when it was first assembled. The inside of the structure is slowly locking itself into place, reinforced by the very environment it is designed to survive. Even a narrow opening can allow water to work its way into the structure. So using traditional methods refined over generations, they prepare a strong sealant mixture of resin, lime, and cow dung paste. Then, working by hand, they press it deep into every joint and seam, making sure no space is left unprotected. A final layer of natural oil is then applied across the surface, strengthening the seal and adding another layer of protection. Boat building is far more than assembling pieces of wood. It is a craft shaped by centuries of trial, error, and hard-earned lessons from the sea. Every vessel begins as an idea, but turning that idea into something capable of crossing open water demands thousands of decisions. Each timber must be chosen carefully. Every joint must hold. Every curve, measurement, and connection must serve a purpose. In traditional wooden boat building, the process starts with a clear understanding of purpose. Builders must know exactly what the vessel is expected to do, where it will operate, and the conditions it will face once it leaves the safety of the shore. Nothing is added without a reason. Every beam, plank, and frame serves a specific purpose, and as the vessel gradually takes shape, one truth remains constant. The strength of the whole depends on the precision of every joint, every connection, and every decision made along the way. Whether built for fishing, transport, or exploration, every boat is created with the same challenge in mind: surviving a world that never stands still. Out on the water, conditions can change in an instant. Calm seas can become rough. Gentle movement can turn into relentless force. Every wave, every shift in weight, and every change in weather places new demands on the vessel. That is why the structure must do more than simply be strong. It must adapt. Builders shape, bend, and join the wood in ways that work with its natural properties, allowing the hull to absorb stress without breaking and flex under pressure without losing its strength. It is a careful balance, one refined through generations of experience. Too rigid, and the vessel can crack under strain. Too flexible, and it can lose the strength needed to endure. Somewhere between those extremes, the builders create a hull capable of working with the sea, rather than constantly fighting against it. The transformation is taking place overhead. The cabin begins to rise piece by piece as workers fit additional framing members into place. New sections are carefully aligned, secured, and reinforced, gradually turning a skeletal outline into a structure capable of withstanding years of use at sea. The challenge is that the cabin must withstand more than its own weight. Out at sea, it will be exposed to constant vibration, shifting loads, powerful winds, and the endless motion of the vessel beneath it. Any weakness hidden in the structure today could become a problem years later when conditions are far less forgiving. To prevent that, workers reinforce key sections as construction advances. Additional supports are fitted into areas expected to carry the greatest stress. Connections are checked repeatedly. Adjustments are made wherever necessary. Nothing is left to chance. Trim pieces are installed next, gradually refining the cabin's shape and tying the structure together. While these components add visual definition, they also serve a practical purpose, strengthening joints and helping distribute forces throughout the framework. As the reinforcements are completed, the cabin begins to feel noticeably different. What was once a collection of individual components is gradually becoming a unified structure, with each new piece contributing to the strength of the whole. Workers continue moving methodically from one section to the next, inspecting alignments, securing connections, and ensuring that every element performs exactly as intended. Small corrections are made along the way. A support is adjusted, a joint is tightened. The trim pieces installed moments earlier start to reveal the cabin's final form. Lines become cleaner, edges become more defined. For the first time, it is possible to see not just the framework of a cabin, but the beginning of a working space where the crew will navigate, take shelter, and spend long hours at sea. Yet appearance remains secondary to function. Beneath the growing shape, every component is expected to share the burden of waves, wind, and constant motion. The structure is being prepared not for calm conditions, but for the demanding environment that awaits beyond the harbor. With each reinforcement secured and every connection verified, the cabin moves one step closer to completion. Another phase of uncertainty is left behind, and the vessel continues its transformation from a collection of timbers into a boat capable of facing the open water. With the cabin structure taking shape, attention turns to another critical part of the vessel: the deck. At first glance, it may seem like a simple surface, but out at sea, the deck becomes one of the hardest working parts of the entire boat. Foot traffic, saltwater, sunlight, and changing weather will test it without pause. Meanwhile, another phase of the project begins quietly in the background. Technical work is now underway. The wooden structure is now firmly in place, and the builders turn their attention to a threat that never stops working against a boat: water. To strengthen the hull and protect it from years of exposure, layers of fiberglass mat are applied across the surface. Then comes the resin. Workers saturate the fibers, ensuring every section is fully bonded to the wood beneath. The process demands patience and precision. Too little resin can leave weak spots. Too much can add unnecessary weight. Every pass must be carefully controlled. As the resin penetrates the mat, a transformation begins. The separate fibers and timber gradually become part of a single protective shell. What was once exposed wood is now being sealed beneath a tough outer skin designed to withstand the harsh realities of life at sea. Once cured, the fiberglass forms a strong, watertight barrier that adds protection without significantly increasing weight. Moisture is kept at bay. Abrasion from daily use is reduced. Even marine growth finds it harder to gain a foothold. The change is dramatic, but much of its importance remains hidden. Because this layer is not built for appearance. It is built for endurance. Another line of defense in a vessel that will soon face years of saltwater, weather, and constant use beyond the safety of the boatyard. As the hull grows stronger below, work on the cabin continues with a method that has proven its value through generations of boat building. The builders follow the traditional panel and frame approach, beginning with the construction of a rigid framework made from durable hardwoods. But the challenge is not simply making the cabin strong, it must also cope with change. Wood is a living material. It expands when moisture rises and contracts as conditions become drier. Out at sea, those changes can happen constantly. If the structure is too rigid, stresses can build over time, leading to cracks, distortion, or premature wear. To prevent that, the wall panels are carefully fitted within the framework rather than being locked tightly into place. The design allows the timber to move naturally as humidity and temperature change, relieving pressure before it can become a problem. The builders focus on a set of components that will remain largely hidden once the vessel is complete, but whose importance cannot be overstated. Heavy cross members are positioned across the hull. These timbers act as powerful tie beams, locking the two sides of the hull together. Without them, the immense forces generated by waves, cargo, and constant movement could gradually push the structure out of shape. But the reinforcement does not stop there. At the center of the hull, workers begin securing thick metal plates. Their job is not only to strengthen the hull against the repeated impacts of rough seas, but also to help support the substantial weight of the engines and mechanical equipment that will soon be installed. Hidden beneath the finished deck, these components may never be seen again. A boat can have a strong hull, a solid deck, and a carefully built cabin, but without power, it remains motionless. Below deck, preparations are underway for the mechanical heart of the vessel, the engine. This is the system that will transform fuel into motion, allowing the boat to travel far beyond the safety of the harbor and carry out the work it was built to do. The process begins with a precise chain of components. Power generated by the engine is transferred to a drive shaft running through the length of the hull. The shaft passes through the stern and connects directly to the propeller at the rear of the vessel. It sounds simple, but every part must be perfectly aligned. Even a small error can create vibration, reduce efficiency, or place unnecessary stress on the structure. Installing the propeller may seem straightforward from the outside, but beneath the surface, a series of precise steps must be completed before a single rotation can take place. The process begins with the drive shaft. Supported by a cutlass bearing that ensures smooth rotation, it must pass through the hull with exact alignment. There is little room for error here. Wood is a living material. It never truly stops moving. Even after construction is complete, the timber continues to respond to its environment, expanding and contracting as temperature and moisture levels change. A rigid coating would eventually crack under that movement, creating openings where water could begin its slow work of deterioration. The builders divide the hull into two very different worlds. The line that separates them is known as the boot top, a narrow boundary that marks where the sea will meet the vessel day after day. Above it, one set of challenges awaits, below it another. Everything above the waterline must endure relentless exposure to the elements. Sunlight, wind, rain, and salt all work to wear down the surface over time. To defend against them, the hull is coated with tough, glossy enamels that create a durable protective layer while giving the vessel its finished appearance. But below the boot top, the battle changes completely. Beneath the surface, the hull faces an enemy that grows rather than crashes. Barnacles, algae, and countless marine organisms are constantly searching for places to attach themselves. Left unchecked, they can increase drag, reduce efficiency, and gradually damage the structure they cling to. To prevent that, a specialized anti-fouling coating is applied below the waterline. This protective layer helps keep marine growth under control, allowing the hull to move through the water as efficiently as possible while protecting the timber beneath. It is a final reminder that a boat must survive in two environments at once, one exposed to air and weather, the other is hidden beneath the waves. And once both worlds are sealed, above and below the boot top, the transformation is complete. The hull no longer stands as a collection of materials waiting to be tested. It now feels complete, prepared for the constant negotiation between wind and wave, surface and depth, calm and storm. But even in its finished state, the real test has not yet begun. Because all of this work, all of these decisions only reveal their true value when the vessel finally leaves the safety of the boatyard and meets the water it was built for. As the vessel is moved, every part of its structure is being quietly evaluated for the first time under real conditions. The way it sits in the water, the way it responds to tension, the way the hull behaves when forces begin to act on it outside the controlled environment of the boatyard. Even something as fundamental as watertight integrity is now under observation. Any weakness in sealing, any overlooked gap, would begin to reveal itself once the hull is in motion. One of the most critical points of control inside the vessel is the steering system. Technicians begin installing the steering wheel along with the hydraulic components that will translate every movement into direction at sea. Another hidden phase of construction is underway, one that will determine whether the ship can function at all once it leaves the yard. Fuel lines, oil circulation systems, and exhaust pathways are carefully routed through confined spaces where every bend and connection must be planned in advance. There is no room for improvisation here. Each line must follow a precise path, avoiding structural members while still reaching the engine and auxiliary systems without restriction. A single mistake could mean restricted flow, pressure loss, or failure under load once the vessel is operating at sea. Then comes the moment everyone has been working toward in silence. The first engine test begins. Inside the hull, the air feels different, tighter, heavier. Every technician pauses as the system is prepared for its first real activation. Lines are checked one last time, connections are confirmed. A final silence falls over the vessel, and then power is applied. With the sliding door system now completed, attention shifts to another major structure rising above the deck. The large shelter is beginning to take shape. Beam by beam, workers extend the framework across the vessel, creating a covered space that will shield the crew from the harsh conditions they will eventually face at sea. The builders begin work on one of the vessel's most prominent features, the high-rise racks that will eventually tower above the deck. The process starts on the ground. Long steel tubes are laid out, measured and arranged according to the design. At first, they appear as nothing more than scattered pieces of metal, but slowly their purpose begins to emerge. But before it can be installed, another threat must be addressed: corrosion. Salt air and seawater can slowly attack exposed steel, so the entire framework is treated with anti-corrosion protection and painted in the hull color. Only then is the structure ready. But these racks are far more than simple supports. Once completed, powerful fishing lamps will be mounted along the horizontal sections of the framework. After dark, these lights will illuminate the water around the vessel, attracting squid and small fish toward the surface. Yet, lighting is only part of the story. The towering framework also serves as a rigid anchor point for cables, lines, and rigging used to operate heavy fishing gear. When nets are deployed and equipment is placed under load, immense forces can travel through the vessel. The racks help manage those forces, providing a stable structure capable of supporting demanding offshore operations. And so, after months of labor, the vessel finally stands complete. For a time, it existed only in measurements, sketches, and imagination. Then came the first frame, the first plank, the first challenge. From that moment on, each day brought it one step closer to the sea. Now, it waits. If you enjoyed following this build from start to finish, there's more on the way. Subscribe to follow the next project, and let us know what you'd like to see brought to life next.